Again, my focus is here really on electrical batteries. And this is a little busy, but there probably is a place for most of these technologies within the energy matrix. So as in all electricity, there's always the issue of power, which is the capacity in, I'll just use kilowatts, versus the energy, the kilowatt hours. So depending on the size, how big of a capacity you have, each of those technologies on the previous slide fits into a different size category. And they also, so for instance here we've got compressed air energy storage and pumped hydro, typically are very large. But what's also important in terms of what you're going to use that storage for is how fast can I discharge that capacity. So for the electrical engineering types, you know, if you've got very fast, so you could meet a really needle peak, you've got the supercapacitors. And if you've got the much, you know, slower that can discharge over hours, then again you've got this pumped hydro, compressed air energy storage, flow batteries somewhere in the middle. So those are, you know, the kind of the power versus the energy parameters. And you can see that there probably is a role for almost any technology that you can make economic, which is of course the real question. And that's, you can see down here on this graph, this is a capital cost per unit of power, which is kind of the standard for any type of generator or complementary technology. What is the dollars per kilowatt? And then what is the dollar per kilowatt hour? So you can see then that shifts things into different areas of the matrix. Anyway, in my mind, energy storage, if you can guess who the Microsoft of energy storage is going to be, you will probably retire early. Okay, now we talked about my residential electricity bill. Feed-in tariffs have, they gained a lot of popularity in the German system, in Spain. They, for reasons that we'll talk about a little bit later, have fallen out of favor. They've never really gained favor in the United States. And I think it's because they are a means of bringing in higher cost power that we haven't really demonstrated we're willing to pay for. So here on the left is, I just wanted to, this is exactly my, you know, I get my electrons from the utility, my meter spins, and I pay the utility every month. So that's the typical 1 meter setup. What happens in a feed-in tariff is that now I have to add a second meter. And so my meter, my typical meter for what I use continues to spin the way it always has spun, but now I have some type of an on-site generator system, typically a rooftop photovoltaic, but it could be, in Germany they had provisions for feed-in tariffs for biomass and wind. So my second, really my feed-in tariff meter is a second meter where I'm providing the, so this is basically my generator, I'm providing the electrons to the utility, and the utility is paying me for those electrons. So it's 2 separate meters, 2 separate calculations. At the end of the month, I'm going to end up somewhere here between what I owe them and what they owe me, and one of us is going to pay the other. So feed-in tariff again is going to need 2 separate meters. They don't have to be exactly on the same spot. And the whole idea, you hear a lot about virtual metering, that is where you are, where it's definitely not on the same spot. So if I were to invest in a solar garden, where the solar garden is somewhere where the sun is better than it is at my house, I might be getting a feed-in payment from that solar garden while I'm still paying my residential household bill. Okay, this is a German experience on the solar side with their feed-in tariffs. And the purpose of the feed-in tariff in Germany was really to create a market transformation. They wanted to create an industry. I believe in Germany, and I was not part of that policy debate, but they really wanted everybody to be able to participate in this. And if you go to Germany, you will see a lot of rooftop PV. And this is why. So they started in 2007. They were paying almost 50 cents, 50 euro cents per kilowatt hour. So, and I think was as much a social policy as an energy policy, because you've got a lot of farmers who were able to put solar PV on their barns and reap the benefits. And these were, I think in most cases, these were 20-year contracts. So if you were in early, you would be receiving that 50 cents, 48, whatever the exact number is, 50 cents per kilowatt hour for the life of your contract. And that's pretty compelling. That's pretty compelling to most of us. So again, that's why when you go to Germany, you will see a lot. You'll see way more solar photovoltaics on rooftops than you will if you go to Phoenix. So go figure. And so anytime you have a feed-in tariff, the purpose is to create a market, to move the market, to have additional installed capacity that presumably over time will bring down the costs of that technology. So for it to make any sense, you have to step down how much you're paying for that feed-in tariff over time. And so you can see it's been a significant step down every year. And it ranges by the type, by the size of your installation. And again, you're going to get at the year that you come online, the year that you sign your contract, that's the price you're going to get for the duration of your contract. The reason that feed-in tariffs have not really gained traction in the United States, and there are some exceptions to that, but they're quite limited, is because somebody has to pay for that 50 cent per kilowatt hour power, and in this case, the Germans are going to be paying for 20 years. The way that they've managed that is that they have a renewable adder on their electric bills, and in 2013, the last number I saw was about 5.5 euro cents just for the adder. So that is, it has raised some eyebrows, and I think that's one reason, again, why you're not seeing feed-in tariffs really gaining traction in the US, because we just haven't demonstrated our commitment to paying those additional costs. Okay, gee, have to have greenhouse gases and climate change. It's not just about carbon. We talk about carbon, we talk about CO2, and everything is actually indexed to what's called the global warming potential of CO2. And the global warming potential is kind of a 100-year view, because CO2 is a long-term global issue. So everything is kind of based on this global warming potential over the long term, and everything is indexed to carbon dioxide, 1 ton of carbon dioxide having a global warming potential of 1. But there are a whole bunch of other greenhouse gases. There's actually about 24 of them, because when you get to these fluorocarbons, there's multiples of these, and a lot of these are very specific, used in capacitors, or have some very specific, but they nonetheless, if certain perfluorocarbons have a global warming potential that is, thousands of times more, has thousands of times more impact than CO2. So this was new to me when I first got into the kind of CO2 debate. Also methane, which of course is the major component of natural gas, and this number you'll see at 21, 23, 26, point being that it's much more, has much more impact in terms of global warming than carbon dioxide, which is why there's a lot of concern as we increase our use of natural gas around the globe for leakage from pipelines and compressors, because it is has such a greater impact. Because we don't want to be talking about all these different things, we lump them together in greenhouse gases, and we put everything in terms of carbon dioxide equivalents, CO2 equivalents. So 1 ton of methane is going to be 21 CO2 equivalents. Almost always, because the US is the exception, almost always you'll be talking in metric tons, which is 2,200 pounds, up to 1,000 kilograms. And because when you're talking carbon, you end up with such huge volumes. Usually you'll see that in millions or even gigatons. So, wanted to just include a little bit of background on, where does all this CO2 come from? Because I think it's not always obvious. The climate scientists have, scientists, I guess, have said we really need to stabilize CO2, the concentration of CO2 in the atmosphere at 350 parts per million. And you can see here in this little inset from 2009, we've already started to climb above the 350, and in May of 2013, for the first time in recent history, there was a measurement of 400 parts per million at, I think it was at Mauna Kea in Hawaii. And that caused a lot of alarm among the climate scientists, excuse me.
Who's establishing the target? It's an international?
It's the,
So it's not just the United States?
no, it's an international organization, and it's the, somebody help me with the...
Is that it IPCC?
Yes, the International...
Oh, Panel on Climate.
Panel on Climate Change, right here, yes, thank you. Yeah.
Huh.
And so this is a figure from the most recent synthesis report that they did in 2007, just showing the sources of CO2. And, you know, we all hear about fossil fuel, and that is, you know, the lion's share of it. But there's also a lot that's related to the deforestation. As we cut down trees, we are losing the ability for those trees to absorb carbon. And also just decay, you know, we've got a lot of peat and peat bogs, they tend to emit CO2. There's a lot of CH4, this would be the methane, so this is again converted into those equivalent gigatons here of CO2. A lot from agriculture, you know, feedlots, cattle, and then we've got the N2O, which was also one of the greenhouse gases from agriculture. And then right here on the top, you can see those very small line, but those large impact, small volume F gases. And if you look at how that breaks down, this is similar to this in a pie shape, but where it comes from, I think, is also very interesting. Again, you've got a big chunk of it from our energy supply, also a fairly big chunk from deforestation, agriculture, industry contributes, even our residential and commercial buildings, and of course transportation. So, a little bit on greenhouse gases. Okay, H, hedging. We always talk about the volatility of fossil fuel prices. And this is in nominal terms, so the dollars of the day. And it's taken from EIA. And it's really what we're paying as at the consuming end. So, for instance, on the natural gas, the green, which is, of course, very volatile, you can see how we had the big peak in 2008 when really everything was peaking, and then we can see the impact of partly the recession and partly shale gas. And we're seeing that in electricity prices, you know, crude oil, who knows what's driving that market, you know, coal, and then we've got the oil products here. So one of the things that fossil fuel does, you have a larger upfront capital cost, and you may have some additional O&M costs, but you don't have fuel costs typically. So one of the value components of renewable energy that is alluded to but difficult to quantify is what's the value of knowing what your fuel cost is, that it's going to be zero for the next 20 years. What is the value to you of not having to pay natural gas prices or not having to pay the electric bill? And that's going to depend, there's going to be some personal preference in there, but it's a value that I think we would all implicitly agree is not zero. Okay.
Excuse me?
Yes.
On the, I'm surprised of seeing the shape of electricity and gas prices. Is that because it is reflecting like seasonality, or? That
would probably be summer seasonality. We tend to, because of the electric, the air conditioning load.
And also, well, I cannot very well distinguish if the green or blue is gas or electricity. I suppose
this is gas, and the blue is the electricity.
Okay, so it is following the crude oil price, but I was thinking it would follow it more precisely. The
natural gas?
Yeah.
We have seen it. I think you can see here that the linkage between gas and oil was stronger. Since the shale gas has started to come on, I mean, we've always been a North American market, and these are US prices. So we don't have the impact of foreign natural gas prices that are tied to oil. This would be different. You'd see a greater linkage, particularly here, if you were looking on a global, but then what pricing would you use?
There is no like indexation? Or?
There's not much linkage anymore between oil prices and natural gas prices in North America because of the increased production of natural gas. Yeah. But that was always a big topic of discussion, you know, what's the correlation between natural gas and oil? But it's really not very strong anymore.
Yeah.
Okay. Okay. Electricity, you know, the most volatile of all of the commodities because it is really priced in real time. So this is just from last week, a week and a half ago. We've had a massive heat wave in the Northeast, and this is just showing for the New York ISO, so the Independent System Operator. New York is broken up into a number of zones. You can see they've kind of cut the state, and you've got Long Island here. And then you've got New York City sitting on the tip here. And you can see, you know, they're kind of going along. It's not terrible. You see some pricing during the peak of the day. But then you see these 3 days where you get, you know, prices approaching $1,000 a megawatt hour because of that heat wave and their need to bring on a lot of really inefficient peaking generation. So again, what's the value of being able to hedge against this? It's going to vary by your application. Okay, this is the solar insolation map for the United States, Germany, and Spain. And so you can see Germany is really similar to Alaska when it comes to solar resource. First time I saw this map, I scratched my head and said, you know, why does Germany have any solar at all? And again, I think because their policy purposes for having their Feedin tariff program were driven partly by social policy, perhaps partly by the fact that they're at the end of the line for Russian natural gas. I mean, there's a lot of drivers that are not necessarily purely economic. Spain, much greater resource. They went through a Feedin tariff experiment, really, and I believe they were deemed to have overpaid severely. They got contracted out very quickly and stopped their program also very quickly. So you can see in the United States, obviously in the Southwest, is the greatest solar resource. It is shocking to me when you fly into Phoenix, you are lucky if you see maybe 1 or 2 solar rooftop installations. And of course that's all driven by policy. APS has not had strong incentives for solar, even though their load is highly driven by the same things that the sun drives, which is air conditioning load. So, I just think that's a really interesting map. And so the thing with the solar potential, which is referred to as insolation, is it varies by place, clearly. It also varies by the time of day because the sun comes and peaks and sets. And it also varies by season because of the angle of the sun at the different times of the season. I don't know if you live in a city, you're not as aware of the fact that the sun's setting in really different places every day of the year. But yes?
Do you think that in other countries there is more of a tax incentive for a residential homeowner to put solar panels on? Because I'm from Texas and we have sun, but the sheer cost of putting solar panels on my house, in a house I may not live in for more than 5 or 10 years, is far outweighs any benefits I would get. Is it different in other countries?
You know, I don't know. In one of the ways to get around that has been discussed here is to actually include the cost of your PV system in your mortgage, so that it goes with your mortgage. So when you sell your house, pay off the bank, that's part of the sales price of your house. And so that's another way, because it's very difficult for most of us to get over that initial cost hurdle without some type of incentive. And then we put a new roof on several years ago, and we live in Colorado, perfect place to have solar. Our house isn't quite angled correctly, and we have a number of large trees that we really would have had to take out to make it pay, and we weren't willing to do that. So there's a lot of, and different people, this doesn't really go to the tax policies, but there are those cost impacts. There's a bunch of different tax incentives that tend to step down like they did in Germany and California. They had the California Solar Initiative. We've moved away, however, from the upfront payment of a capacity-based payment to more of a performance-based payment, because what people were finding was we paid for half of your system, and then, or most of your system even, and then you had no incentive to maintain it and have it actually producing. So utilities have moved away from that upfront capacity payment to more of a performance-based, we're going to pay as we go. Or some hybrid of that, because they recognize that most homeowners don't have the $10,000, $20,000, or $30,000 up front. Yes?
So I'm just wondering about the efficiency per dollar for a residential solar PV array compared to a commercial array. So if like, let's say California decides, okay, we want to spend $100 million on photovoltaics, is that money per dollar better spent on a residential array or a commercial array?
You anticipate my next slide.
Okay.
This is just one example. So if you have a rooftop photovoltaics, typically we say the load factor, conversion efficiency, that's actually they're different things. I'm kind of mixing metaphors here. You're going to have a more efficient system if it's larger, no doubt about that. That's where you get into, so what is the value of having it on your rooftop and avoiding the need to use the distribution system? So that's where the policy aspect comes in, and do you just want to involve your utilities? In Germany, I think that was a very clear social policy that we want to not only have this resource, but we want to have really every homeowner, anybody who has a rooftop, we want them to be able to participate in this. So I think there's...
So it goes beyond the actual, let's produce electricity.
Yes.
Okay.
Yes, I think there's always, policy always has a social overlay, and depending on where you are in the world, I think that is stronger or weaker. So there's definitely economies of scale. You lose some things, and actually I'll have a slide that was kind of a precursor to the California Solar Initiative where we tried to value that rooftop PV. That'll be my cue slide, so stay tuned. Was there another question? No. Okay, so I switched a little bit here, and instead of insulation, I have inverters. I think this is the only slide where I use two eyes. You have to have an inverter because photovoltaics generate direct current, and in most places in the world, you have to have alternating current if you're going to feed into the grid or if you're going to use it in your home. So this is just a small, here's the sunlight, or so our insulation coming in, being converted. And then actually this doesn't show the inverter, but you need the inverter right here in order to get your light bulb lit. And again, just a kind of small lesson on